Hi, what's up guys? It's Josh Paul back here again at O-Chem Simplified, and today we're going to be discussing about isomers. We're going to be talking about two main types of isomers, which are going to be constitutional isomers and stereoisomers. The whole goal of this is to prepare you for those test questions and those quiz questions where you're going to have to compare different molecules and see if they are, for example, enantiomers or diastereomers, or if they are the same compound or different compounds. For the most part, those are the types of questions that you're going to see on your exam and on your quizzes. So it's very important that you understand the proper way of breaking down this information to help you realize when you're given a complex problem, you don't have to use bond rotation or pull out your molecular set kit to actually connect the molecules together and turn it around and try to impose them on each other, right? We're going to teach you the proper way of analyzing this information and getting you ready for that exam. So without further ado, let's go right ahead and talk about isomers in general. So isomers essentially are the same molecular formula but different spatial arrangement. Right? So isomers are going to have the same number of carbons, same number of hydrogens, same number of oxygens, whatever constitutes that molecular formula. Isomers are going to have all of that. It's going to be very consistent, but how the molecule is connected, how those atoms are connected, the spatial arrangement, the orientation, that is what's different about isomers. An example of this, right, could be your hands, right? Your hands, you have a left hand and you have a right hand. Your hands are essentially identical. You have 5 digits on each hand. You have a pinky, you have a thumb, right? But the only difference is that one is your left hand, which is spatially orientated in a different fashion, while your right hand is also spatially orientated in a different fashion than your left hand. But your hands are still pretty much identical. So that's the same type of logic that you should use to understand what isomers are, right? They're going to have the same molecular formula, but how the atoms in that molecule are connected or spatially orientated are going to differ, right? So the first type of isomers that we have are going to be constitutional isomers. Essentially what that means is that you have different connectivity with the same molecular formula. An example of a constitutional isomer could be this, right? Say we put 2 ethyl groups here on this cyclohexane molecule. So we have 2 ethyl groups on this cyclohexane molecule, and say we draw another cyclohexane that also has 2 ethyl groups, right? But instead of them being on our 2nd and 3rd carbon, let's put that on our 1st and 4th carbon, right? When we're looking at these two structures, we see they have the same number of carbons, the same number of hydrogens, right? But how the atoms inside the molecule are connected differ. Therefore, we would refer to these molecules as constitutional isomers. Same molecular formula, different connectivity, right? So that's the first type of isomer that we're going to be dealing with, right? Next up, we have stereoisomers. Now, stereoisomers are a little bit more complex because now we're looking at the same connectivity but different spatial arrangement, right? So let's go back to the example of our hands, right? Our hands, our pinky is going to be the last finger, right? And our thumbs are going to be right here. We're going to have our index finger, we're going to have our middle finger, ring finger, pinky finger, right? But what do we know about our hands? They are non-superimposable, meaning there is no way that I can orientate my hands for them to stack completely on top of each other. There is no way that that is possible. What that means is that we have a different orientation in terms of spatial arrangement. So now let's get started. We're going to dive straight in to discuss how we can tell if a molecule is an enantiomer or a diastereomer. And these both fall under the category of stereoisomers. So we have enantiomers, and then we have diastereomers. Right, so these are the two main types of stereoisomers that you're going to be dealing with, and we're going to dive right in to see examples of how to differentiate between an enantiomer, a diastereomer, or something that is a constitutional isomer, or molecules if they are the same compound, or if we're dealing with completely different molecules in general. So without further ado, let's talk about that right now.